The world is a wild and unpredictable place. And isn't that absolutely amazing? Products can catch fire overnight. A back-of-the-napkin idea can change the world. An incurable disease can suddenly appear vulnerable. So many wonderfully improbable, never-before-possible breakthroughs are out there, waiting to be discovered. And with Amazon Web Services using custom Intel technology, you'll be ready for anything. Ready to unlock a human genome, to cure a debilitating disease, to go to another planet, to teach the world a new language, to fuel the world. Because you'll have Amazon Web Services featuring custom Intel technology at your fingertips. Because AWS and Intel engineers have worked together for over a decade to make sure you'll be ready. And because you'll have AWS's most innovative and powerful cloud service platform to help you make the impossible possible. That is the power of AWS with Intel. So go ahead, chase the moonshots, double down on what's working, pivot from what isn't. With Amazon Web Services and Intel, you can charge toward the unknown, ready for anything, and ready to change everything.
Good morning, Singapore. It's a pleasure to be here. First in the series of AWS summits across APAC. This is mind-boggling. A very warm welcome to all those from Singapore and folks that have come from around Southeast Asia. I have been to quite a few AWS summits, and each time I'm amazed at the customer stories that I hear and the innovation that you all have driving. This one has raised the bar again. A bit about my role. I oversee Intel's engagement with Amazon across sales, business development, and marketing for APAC and Japan. We have a team at Intel that is dedicated and focused on working with AWS engineers to build EC2 and all the services around it. A large part of AWS infrastructure runs on Intel technology. The great part about my job is I get to take these services and technologies to end customers along with AWS in various markets. Many of you know Intel as a silicon company for the past many years, but we do much more than that. In fact, within Intel, we have a software and solution group with thousands and thousands of people working there. And if you were to spin that out, it would be the third largest independent software company in the world. Having said that, this session will be co-presented by Akanksha Bilani, head of Intel Software for APAC, and myself. And the goal over the next 40 minutes is really simple: to share with you the Intel technologies that are available on AWS and the software tools that you can use to make your analytics and deployment scalable. Now, with any Intel presentation where we are talking about performance and benchmark, there is a legal disclaimer which is here. All the benchmarks and metrics that we will share are publicly available, and we have worked hand in hand with AWS to publish these. So we want to talk to you about three things. First, the AWS and Intel collaboration from edge to cloud and the solutions that we have built. Intel's AI portfolio, the technologies and the frameworks and libraries that are available on AWS Cloud, and application of AI to real-world use cases. You will see a common theme, a common thread that spreads around all these topics, and that is data. At Intel, we believe that data is the most valuable commodity on the planet, and every enterprise should have a strategy around data. Just before this track, I was talking to a gentleman in the audience from Thailand, and they are exploring how can they leverage terabytes and terabytes of data to get more deeper customer insights and do predictive analytics. So it's a very real-world use case. So let's take a look at one such real-world use case where we have applied we have applied technology and transformed the way data is collected and analyzed. I want to share a collaboration between Intel and Parley for the Oceans, where we successfully deployed advanced drone technology and machine learning at the edge to collect and analyze data from the whales. Let's watch a short video, and we'll talk about it a bit more. Please roll the video.
We're really at the beginning of this whole new era of whale research. In the past, I collect the data, I go back home, and I spent months sorting through it. The fact that Intel's giving us the opportunity through AI to review the data streams as they're coming in with the computing power to match and compare images means that I can be much more efficient in the field.
We really believe that drone and artificial intelligence technology together can make it possible to both identify the whales and give them a health score, which gives us a good idea of the health of the whale and, by extension, the ocean. The algorithms that we use can look at an image of the fluke or the tail to identify the whale. It can pick up on patterns that we can't even see in terms of the shape of the fluke, the color of the fluke, the speckled patterns on the fluke. And that's really useful. It may take years for a human to figure out what features matter, but for a good machine learning or artificial intelligence algorithm, that can be done in seconds.
The fact that I can be standing half a mile off from a group of whales, listening to them, measuring them, collecting biological data, processing that data with Intel, I mean, it's making all of this incredibly cost-effective.
The health of that water is key to human health, and whales are a great barometer to the health of the ocean. And so by studying them, we get a good sense of how we're all doing.
Wasn't that amazing? So this is a great example of where massive amount of data can be collected at the edge, sent to the cloud for real-time analytics. The AI applied on this research project gave valuable insights into things like the weight of the whale, health of the ocean, which then translates into health of the planet for us. Intel's strategy is centered around data. We want to power the compute, networking, and storage in the data center, and we want to make it seamless to connect it to the edge devices. We have huge investments in networking and 5G technology. We have a massive group that is focused on Internet of Things and is building Intel technology into things like farming equipment, ATM machines, all the way to sophisticated drones. Our collaboration with Amazon is a perfect example of this virtuous cycle of growth that is centered around data. As you can see here, back in the cloud, in the AWS cloud, EC2 instances, S3, EBS are powered by Intel compute, networking, and storage. Then on the edge, we have an amazing partnership with the Alexa team on devices like Echo Show and Echo Look. For example, in Echo Look, we have Intel 3D cameras that bring computer vision to life. Also, every time someone sends a query to Alexa, the request goes back to AWS Cloud, and this is what really drives the growth and the flywheel effect. More data at the edge, more devices at the edge, more compute and analytics either at the edge or back in the cloud. One of the products that I'm particularly excited about is the DEEPLENS camera that AWS announced at reInvent last year. We will talk about this a bit more later on in the slides. But you can get hands-on with DEEPLENS, take a look at what it can do in terms of machine learning and image inference at the edge at our booth in the exhibition hall. So going back to that virtuous cycle of growth, to the top end of it, where we have the AWS cloud, this graph gives you a visual representation of the complex and the wide variety of workloads that run in any data center. These are mapped along two dimensions, I/O intensity and memory intensity for these workloads. Each workload has a different profile in terms of computing, networking, storage, and memory requirements. And this is the big driver why Amazon in AWS have the wide variety of instances that they have. Initially, when AWS started, there were just two instances, EC2 and S3. EC2 for compute and S3 for storage. If I overlay this with the instance family, you can see how Amazon and AWS Cloud have the compute and the infrastructure necessary to cater to these broad workloads that run in a data center. The one that I'm particularly excited about, and I want to talk in fair amount of detail today, is the C5 instance on the top right there, which went into production late last year and is available in the Singapore region right now. C5 is based on the latest Intel Skylake generation of CPUs. It has 2x the number of virtual CPUs versus what were present in C4. C4 instance family is an amazing family of instances. And when it was launched, it flew off the shelf because customers saw the performance value and the TCO benefit in migrating from legacy instances to the latest C4 family. But the delta in performance and the TCO value in migrating from C4 to C5 is much higher. Here you can see a quote from Dr. Matt Woods, who is the GM for artificial intelligence at AWS, and what he said when C5 was announced last year. Based on the optimization work that we have done on the software side and on the performance improvement in the silicon, there is a 100x improvement in deep learning inference workloads when you run it on C5 instances on Skylake. This is phenomenal. The other critical aspect of this and getting the performance value and TCO is that these instances are broadly available in most regions of Amazon. They're not limited to US or select regions across the world. So, some more details around C5. We have been working with a partner called TSO Logic. They specialize in doing TCO calculations and analyzing the on-prem workloads that customers have and what they could potentially save by moving it to cloud. They also look at existing workloads in the cloud for a given customer and make recommendation on how you can optimize and save by moving to newer or different instances. They looked at hundreds of customers that they have currently, and what they found was truly amazing. 20% of those customers would save approximately 18.5% by simply moving their workloads without any optimization, without any changes from a C4 instance family to a C5 instance family. Now, there are a couple of benefits that come with the C5 instance family just besides performance and TCO. So you get performance and a higher core count with the C5 instance family. But what it also means is that you can run this on far fewer AWS instances. That reduces your licensing cost, and hence the overall TCO value proposition becomes significantly higher. The table that you see here, and I'm sorry, it's a bit of an eye chart and may be difficult to read, but it's pretty simple. Each of the rows here is a comparison between C4 and C5 in terms of cost. So right off the bat, by migrating workloads from a C4 instance family to a C5 instance family, you tend to save 15%. Moving on, and sort of this is the last point that I want to highlight on the C5 instance family. This slide highlights the performance benefit for deep learning workloads on C5 when you optimize your code with Intel's math kernel library. Inference being when you have trained your model on AWS and are using that model to cross-reference with other data sets and images. And if that model has been optimized with math kernel library, you will see an improvement of 7x to 10x in your deep learning workloads. And this is again huge and significant. For a minute, think about Alexa, and whenever you send or talk to Alexa, the query goes back to the AWS cloud. And when you have millions and millions of devices, either first party or third party out at the edge, it is a significant performance improvement and directly impacts your bottom line. So moving down to the bottom part of that virtuous cycle of growth where we have connected edge devices like the Alexa and the DEEPLENS. This was announced at reInvent last year, and I want to highlight 4 key things about DEEPLENS and why it is a great computer vision device at the edge. First, it runs on an Intel Atom SoC and has enough performance headroom to run deep neural networks at the edge. Second, not only it has enough headroom to run complex libraries at the edge, it stays within the thermal budget of a mobile device. The third element of it is Atom SoC comes with an integrated GPU and an image processing unit, which makes it a very great computer vision device. And lastly, because it is x86 architecture, moving your workloads and trained models from the cloud to the edge device is pretty seamless without any change in the code. So, having said that, I hope you have got a sense of the deep and the broad partnership we have with Amazon and the technologies that we have enabled both in the cloud and at the edge. Now I will hand it over to Akanksha to go over into some of the frameworks and technologies that are available to you to build your software, build your code, and deploy it at scale. Please welcome Akanksha.
Thank you, Kapil. I completely echo Kapil's excitement in being here in front of you guys today at the AWS Summit. I want to congratulate our partners, AWS, for putting on such an amazing show. Who would have thought we'd get 7,000 people to come into a conference in Singapore? I thought we'd have to ship people all the way from India to get here. So this is amazing. With us in the industry, time and time again, what we've recognized is when you have a technology that's easily accessible, that's easily consumable, and the barriers of its adoption, if they are low, this gives a rise to a crazy amount of demand. And through that demand, it evolves into various business models, lots of usage models, which basically also gets us rise to a lot of opportunity. Cloud computing on AWS is one such enabler. It is a fundamental benchmark that makes so many different things that are awesome possible. What we've also recognized is along with the demand and the opportunities that we get as part of the technology drive, it also gives a crazy amount of drive into data. I like to call these personal devices or people's devices, laptops, tablets, PCs, smartphones, and what have you, are really changing the way people communicate with each other. There's a survey that predicts that by the year 2020, we're going to have 50 billion devices and over 200 billion sensors, smart and connected over the internet. And most of these, over 40% of these, are going to communicate machine to machine. What does that do? It gives a rise to a surge of data. And that's where Intel comes in. There are 3 things that Intel does to help you analyze and take advantage of that data that's available to you. Number 1, if you paid attention to Kapil, you already know this: performance. Number 2, performance. And number 3, any guesses? All right, let's turn it up a notch. Extreme performance. So the combination of data with the compute that Intel brings onto the table really helps work together with partners, developers, and ecosystem members like you to build strong and competitive solutions for artificial intelligence. So AI really is transforming every way that we really exist and live. But a lot of this has to do with, oh, sorry, I'm a slide ahead of my curve. I have some AI going on inside me. Anyway, so going back to the industries that are kind of leading the transformation from an AI perspective, we have 3 or 4 different factors that really drive that change or the adoption. Number 1 really being, do you have established clear use cases? Second, do they have a high purchasing power? And second, do you have high rewards for making quick decisions for accurate adoption? AI is so much easier for adopting if you've got this environment going. And of course, I'm not going to touch on each one of these segments, but of course, consumers really do know how to take advantage of artificial intelligence. If you look at Alexa or the smart assistants, let's look at finance with fraud detection or KYC type of applications. I know the Singapore government is a great benchmark of trying to augment the smart cities with the artificial intelligence boom, transportation, and what have you. So it really doesn't matter which industry you're from, as long as you've got the factors that really help you with the adoption of AI locked in, you could be an early adopter in that field. There's a recent Forrester survey that says that 58% of developers and companies are thinking about doing something on AI, research something on AI. But the actual adoption rate is down to 12%. These are the only ones that have really got some AI systems going. So there's a huge gap. And that's a factor from the type of data that's out there to the actual use cases that are there. So there is a small gap. We do see that changing in the decades to come, where software becomes a lot more important, where software vendors and the industries that drive the software revolution work together to build stronger consumer experiences that builds better pricing structures and better products and services that help you adopt AI and bridge the gap between the 12 to the 58 and take it to the next level. Now that we've kind of established the business imperative of why AI is kind of upon us right now, let's talk a little bit of theory about approaches. How do you really adopt AI? What are the different approaches that you could take to actually demystify the myth of artificial intelligence? Let's start with the first one of cognitive reasoning. When it's easy to detect the similarities and anomalies in a large sea of data, where you've got fully explainable as well as real-time updates that are very important within your systems or on your customer systems, you want to adopt cognitive reasoning. This is very popular in FSI, in the finance segment, so a lot of you fintechs probably already know this and are adopting it. Credit card fraud, issue and detect, as well as predictive maintenance are really great examples of such type of approach for AI. The one that's typically used in current market today is machine learning. And this is a subset of statistical and algorithmic program models, which really help you identify the problems that you're dealing with and work on reverse engineering that into your environment. When there's tabular data, when you have good enough accuracy, when it's kind of sparse but still okay to train and to control and score on, that is where you adopt machine learning. And this is great for statistics, for regression, and feature extraction. The one that's kind of last but definitely not the least, and getting to be quite incumbent and popular, is deep learning. This is adopted when you have difficult problem statements that aren't able to reverse engineer, when the data sets are large and uniform and they have high levels of accuracy, where your predictions are very, very important for inference. This is really valuable in image recognition and speech recognition and natural language type of environments. So there are obviously a lot more ways of subsetting it, but this is the way Intel looks at it, to kind of demystify how this is so much easier for you guys to think about when you're thinking about building tangible solutions on AI. So business imperative approaches, completely locked down. Let's talk a little bit more about what Intel has to offer from an AI portfolio to help you deliver tangible and solid, complete solutions on AI. And I'm going to touch on each of them layer by layer. Let's start with what we're good at. Yeah, our technology. See, we got an applause already. Intel's product portfolio for our technology is massive, and it has the promise of providing you the end-to-end compute. So we have hardware and our processors that are set from data center to the cloud to storage to the gateways all the way to the edge. Kapil talked about the XEON Scalable processor family that has built-in capabilities for helping you adopt AI into your infrastructure and into your environment already. And then all the way to the edge, we have the Movidius components, which also Kapil mentioned, and are the evolution of the DEEPLENS capabilities that we have that are available with AWS. So SKYLAKE, or the XEON Scalable, is already available on the EC2, C5, as well as the M5 instances, as we mentioned, and that's something you definitely want to try out. Another thing that Kapil did mention, which I don't think a lot of you people know, is the amount of investment Intel makes into software. We're number 3 in the world when it comes to investments. And the reason we do that, really, is to help the software community get the advantage of our performance promise. We have a set of tools that help you drive better optimization on your applications that are stronger, faster, and more scalable on Intel's architecture. And this is, of course, all boards. We have tools for HPC. We have tools for IoT. Specifically for AI, Intel has gone ahead and invested in a lot of software developer companies or software innovation companies. We acquired Nirvana. We acquired Movidius. We acquired Saffron, Mobileye for ADAS, et cetera, and we will continue to do that because we understand that software innovation is going to drive the change, especially in AI. So in terms of the software libraries, we have a set of mathematical functional libraries that also have deep neural network capabilities under MKLDNN. So how many of you guys program on Python? Yeah, that's a very leading programming language. How many of you know that Intel has its very own distribution of Python? That's a lie I just told you. All right, yes. So we have our very own optimized version of Intel Python to help you build stronger solutions for machine learning. We also have nGraph, which is a deep neural network library that helps you cut across various frameworks that gets the best out of across-the-edge architecture. Let's move on to the higher layer of frameworks. I see, since you guys are at an AWS summit, you guys are probably working on Theano or TensorFlow or MXNet. What Intel has done is also provided its optimization to all the common popular open source frameworks as well. So if you went to GitHub and usually pull down a Cafe or an MXNet, if you typed in Intel Cafe or Intel MXNet, it will give you that advantage by using the Intel optimized framework on your performance benefit. And the layer that sits right on top of it is our tools. And Intel's AI software suite features data scientists and data developer productivity tools that help you compare on various deep learning innovation cycles. So when you're looking at computer vision type of algorithms, you want to use CVSDK. When you're looking at trying to get the best out of the Movidius VPU, you want to look at Movidius SDK. So that really kind of helps you stitch the story and work towards building a tangible, comprehensive solution for artificial intelligence. And the thing that really helps you is our platform. We offer a turnkey, full range of user-friendly systems on the dev cloud or on the deep learning cloud to help you really get the benefit and pull out your cycles on innovation with AI. And the thing that really helps stitch all of this together is the fact that the solutions team at Intel, may they be data scientists, our technical engineers, as well as our reference solution engineers, would work with you on your roadmap to AI to move you from data to insights. So let's talk a little bit more about the XEON processor. This is basically AI on CPU. It provides scalable performance for the widest variety of AI. We've built the capabilities onto our chip. And the bottom line for this is that you don't need to have additional infrastructure investments when you want to try out or early adopt AI. That's significant because it not only does it save time, not only does it save you money, but it also makes sure that the existing data flow is set and you don't need to modify it. And when all you have to do is implement AI into your existing analytics application. So that's huge. That's a huge save in time. It has built-in ROI, as I mentioned. It also gives you potent performance. If you look at the slide up there, 113x square performance gain over the earlier architecture, and helps reduce DL training from days into hours. How significant is that for you guys? I'm assuming very. And of course, we have the robust applications ready, so you're production ready. As I mentioned again, this is available on C5 and M5 instances already. Outside of the layer of the technology hardware, as I mentioned, we also have some libraries that are predominantly for low-level APIs and framework developers. Let's start with the direct optimization. We have the MKL library that is an open source mathematical function that helps you build deep neural networks capabilities on the new frameworks that you might be working on. We also have DAL, which is the Data Analytics Accelerator library that helps you with machine learning pipeline management. And then, as I mentioned, and now that you already know, that Intel already has its own version and distribution of Python. This is important when we want to move along with the boom of machine learning. ngraph also is a great tool, library that you want to have when you want to have hardware optimized executables across different targets. May they be CPU, GPU, or VPU. Intel has made significant investments into optimizing the open source frameworks that are out there. Outside of the ones that I just mentioned, where you could just go ahead on GitHub and enter Intel version of whichever open source frameworks we have, you can also get access to the Neon framework, which is a framework that Intel owns internally and is doing a lot of R&D and research on it right now. Another significant library is BIGDL. I'll talk to you about it in a minute. So BIGDL really is getting a lot of traction from a lot of customers that want an easy way to achieve high-performance deep learning on their existing general CPU infrastructure. So again, no additional investments and performance boom right there. BIGDL is a distributed deep learning library for Spark that can directly run on top of your existing Spark or your Hadoop architecture. And it has support for Scala or Python programming languages. You will see significant performance benefit just by integrating BIGDL into your environment. Also available on C5. So isn't C5 like the best instance there could be on AWS? I think so. If you look at the bar charts over here, by leveraging the low precision and quantization that's available on C5, BIGDL workloads help achieve a 4x reduction in model size and a 2x improvement in inference speeds. And for you data developers and scientists out there, that's really, really huge. We also have a set of Intel tools that help you with your high-level optimization that you need when you're dealing with deep learning frameworks. So DL Studio is out there, computer vision. So when you're working on smart city type of initiatives, video surveillance type of initiatives, where you've got text-to-speech or facial recognitions as huge data points, you want to use CV SDK. And the Movidius SDK, it works best for the VPUs within your edge and your inference-based trainings. All of this is available on intel.com/AI, and we're also working closely with Amazon to have these available, hopefully, on the marketplace sometime soon. And so, outside of the fact that we understand there's a business imperative, we've also talked through the approaches that we could have to adopt AI or build implementable systems on AI, and the plethora of products and services Intel has for AI. Let's talk a little bit about the use cases. And I know that I'm running out of time. I probably won't touch on each one of these, but the key message over here is that we've worked with a bunch of customers and a bunch of partners and ISVs to get great advancements in document analysis for finance, for video activity and video imaging for imaging solutions, for speech recognition, for facial recognition and Siri type of applications. And you can build all of these off of your CPU as a start. So there isn't a significant amount of investment that you have to do. One really cool case study that we have is in the field of healthcare. We worked with a medical image device manufacturer that had a huge challenge with the way in which they were receiving the data. They received the data in such small batches that it built a huge level of latency in the way the images were coming back to them. And so slowed down the entire application, didn't get the results on time, obviously impacted health and benefit of the people that were utilizing that as a facility. When we applied Intel solution, what we did is try to build the productivity onto the memory, and just with that, it helped increase 11x the speed up performance on their infrastructure, and also helped train to detect the tumor images into minutes instead of hours and days. So that was really significant and technically and literally life-changing. Finance and FSI is also a huge segment, as I mentioned earlier, that adopts AI fairly rapidly. We worked with a customer that is a payment processing and a credit card company, a very huge player in the market. They had a challenge of not being able to scale their solutions for predictive maintenance, where they couldn't really take advantage of the data they were receiving from the thousands of merchants and the millions of customers they have. The solution to them was just implementing 2 instances of a BIGDL, where we took a subset of the 24 months of data with 2,000 merchants and over 600,000 customers, and the result was awesome. When compared to rule-based or regression models, this achieved a 50% higher precision rate and 18% better recall. Outside of the fact that Intel works with our partners, with the ecosystem, with ISVs, and obviously industry leaders to drive the adoption in AI, we also want to work with you guys as data scientists, as developers, as students, as professors, and I'm sure there's a lot of you here in the crowd today. Take advantage of what we have to offer. So Intel has launched its very own academy for AI. You could sign up on it for intel.com/AI/AI Academy. Feel free to look it up and sign up. What that really does do is make sure that you can build your capabilities, learn from everything that we have to offer in terms of starting with webinars to workshops to live events, work on developing on the infrastructure that's already available for you through our dev cloud, and also share your experiences with us. It's very important to get feedback from you guys as to how these implementable solutions really are working in real time. And to sum up, let's make sure that we keep learning on the boom of AI. If you went to ai.intel.com, you can get a lot of information. Continue to be a part of these forums where AWS and Intel come together to deliver these technology sessions. Make sure that you explore the latest instances on AWS with the XEON Scalable and the libraries and frameworks that we have out there. And make sure that you talk to us. A bunch of us are around, and we also have a booth in the showcase floor to see if we can collaborate further with you in building some POCs and keep that dialogue going. So I'd like to leave you with one last thought. Before that, though, I do want to thank the entire AWS team that helped us get here today. It's a phenomenal experience, a fantastic vibe. Thank you, AWS team, for having us here and be a part of this. And like I mentioned, the last line, if it's smart and it's connected, it will always work best with AWS, which is always powered by Intel. Thank you.
In the future, I see a new class of chip, one inspired by the human brain, unlocking new possibilities and making the world smarter and more connected. To me, this is the next evolution in artificial intelligence. With neuromorphic computing, we'll redefine what's possible. Self-learning neuromorphic chips will transform education, facial recognition, manufacturing, emergency services, smart cities. It's already here.